Alright, good evening. Tonight our tutorial video will be on multiplication. We're going to do three different things today. The first will be learning powers of 10. The second will be learning the box method, and then third will be reviewing the traditional algorithm. So in this first section up here, this is what we've been working on in class, where we are able to use mental math. If you ever see a question like this that has just a couple of digits and then the rest are all zeros, that's a power of 10. All you are doing is multiplying the digits and then figuring out what place value it belongs in. So in this case, for the first one, we would take the digit 6 and the digit 3 and say 6 times 3 we know is 18. And how many zeros are involved? How many powers of 10 are we shifting this number to? There's 1 0 here, 2 here, so we need 3 zeros. And then throw your decimal or your comma in. Okay. The next one is a bit different because we have an unknown part. So we would say 5 times what equals 10. We know it's not 5 times what equals 1 because that wouldn't make much sense. Okay, that would be a decimal or a fraction. So 5 times what equals 10, and we would say 2. I always box off this number because the 0 can get a bit confusing. We're going to say we had 1 0 here. We are not sure how many go here, and our answer has 3 zeros at the end. So if I have 1 here, blank 3, I'll need 2. 50 times 200 is 10,000. Lastly, I have 9 blank times blank is 54. 9 times 6 is 54. I have 3 zeros in my answer, 2 so far, so I need 1 more to give me 54,000. Of course, you could set up the standard algorithm to check your work, but it really isn't necessary because mental math is so successful in this situation. Next, I want to show you the box method. Your parents are probably used to this method on the right, and this is how I was taught as well, that 43 times 17, we would do the standard approach. I've taught a new way in class, which a lot of students have quickly grasped, and it's called the box method. It's essentially the same as the traditional algorithm. It's just set up in a different format that allows students to see it more clearly. So we break apart the number 43. We're going to break it up into 40 and 3. And the number 17, we're going to break up into 10 and 7. We're going to multiply into each box. So 1 times 4 is 4, and there are 2 zeros involved. 10 times 3, oh, you should know that fact, is 30. 7 times 40, well, I can do 7 times 4 is 28, and there's 1 0. And then I'll do 7 times 3 is 21. We're next just going to simply add them all up. I teach students to add them up in the order of their size, just because it tends to be easier to keep track. 0, 0, 0, 1 is 1. 8, 9, 10, 11, 12, 13. That makes a 6, plus 1 is 7. 731 is my answer. I'm going to check it with the traditional algorithm. You're going to start with the ones place on the bottom number. So 7 times 3 is 21. Put your 1 here and carry your 2. 7 times 4 is 28, plus 2 is 30. The next part I'm going to put a 0 down here. And we talked about in class how it doesn't have to be a 0. It's just a placeholder to tell us not to use that same place again, to move over one. So it could be a star or an arrow or whatever you'd like it to be. Move over to the 1. 1 times 3 is 3. And 1 times 4 is 4. Add those together. That's 1, 3, and 7. 731. So I've done it correctly. I'm going to show you one more problem. In this case, I'm going to do the traditional approach first. In this case, I'm going to do the problem 168, which is, you notice, is a 3-digit number, times 39. Okay? I will start with the same position. 9 times 8 is 72. Okay. Then I say 9 times 6, that's 54, and then I'm going to add 7 to get 61. I place the 1 here and the 6 here. I'm going to do 9 times 1 is 9 plus 6. Should be 15. I'm going to get rid of the 6. I'm going to come down to the next box and place a 0. Then I'm going to do 3. Oh, sorry, I need to get rid of the 7 as well. 3 times 8 is 24. Place a 4 here, carry the 2. 3 times 6 is 18, plus 2 is 20. 3 times 1 is 3, plus 2 is 5. Notice how neat I have to be. 2 plus 1, 2. 5, 5, 6. 6,552. Now, a lot of students may prefer to use this boxed method. Notice my box looks a bit different because this time I have a 3-digit number by a 2-digit number. So I will split up 168 into 160 and 8. Then I'll split up 39 into 30 and 9. Multiply across the boxes. 3 times 1 is 3, and there are 3 zeros. 3 times 6 is 18, and there are 2 zeros. 3 times 8 is 24, and there's 1 zero. 9 times 100 is 900. 9 times 6 is 54 with 1 zero. And 9 times 8 is 72. I will simply add all of those up in a column starting with 3,000, 1,800, 900, 540, 240, 72, and I will get the answer of 6,552. Thanks for watching.